Hi, my name is Yazan Ibrahim, also known as Yazan Abu Ghosh. Today we will talk about Chapter 3, Part A, Information Systems Acquisition and Development 3.4, Control Identification and Design. Picture yourself as the gatekeeper of a vast castle, but instead of brick walls and moats, your defenses are made of data. This digital stronghold is an information system, IS, and it carries the lifeblood of modern business. Information. Your mission? Protect the gates, check what enters, monitor what moves within, and ensure what exits is fit for the world outside. Sound daunting? It's not once you understand the tools and controls that help keep your digital castle secure, precise, and functioning like clockwork. Today we're diving into the fascinating world of information system controls, the fundamental defenses ensuring accuracy, trustworthiness, and reliability across data input, processing output, application controls, and even the tools that support decision making. Ready? Let's go behind the scenes of this intricate invisible ecosystem. Input controls, the gatekeepers of data accuracy. Before anything can happen in an information system, data must enter it. Think of this as opening the castle's gates to traders, messengers, and villagers, but not everything or everyone is welcome. You must verify that only authorized and valid transactions cross the threshold. That's where input controls shine. Here's the checklist every good gatekeeper in an IS follows. Input authorization. Think of it as checking the royal seal. Every piece of data needs approval before entering the system. This could take the form of a signature on a document, an online access code, or unique passwords. These methods ensure accountability and limit access to trusted individuals. Source documents. Imagine a well-prepared inventory log passed between merchants. These documents hold the original data, but a rushed, sloppy note could lead to disastrous mix-ups. That's why templates, clear instructions, grouping of fields, and predetermined input codes are used to make data collection consistent, legible, and efficient. When completed properly, they help you trace the origins and ensure no information slips through. Now, errors happen, a misstep with an input code or a number typed wrong. So, systems employ clever mechanisms like range checks, data must stay within specific boundaries, completeness checks, no missing fields, and duplicate checks to stop the same data sneaking in twice. Think of these as the checks and balances that keep everything accurate, secure, and streamlined. But let's zoom out. What happens when you're not just managing a single input, but a whole group of transactions? Enter batch controls, where data is bundled like parcels on a conveyor belt, ensuring each batch is counted and balanced before moving forward. Whether it's monetary totals, the number of items, or unique codes, each bundle gets tallied and reconciled. Mistakes? They're rejected, marked for review, and corrected without holding up the rest of the process, processing controls, ensuring integrity behind the scenes. Once data enters the system, it's time for the machinery to work. Inside the castle, these are the cooks in the kitchen, the stable hands feeding the horses, the blacksmith forging tools. This is data processing, where raw inputs become valuable outputs. But just like medieval life, things here can get messy. Processing controls ensure everything runs as intended. For instance, sequence checks work like a checklist, ensuring transactions follow an orderly flow and no steps are skipped or repeated. Range and limit controls act like height restrictions at amusement parks, ensuring no outrageous or nonsensical data sneaks in. Like an invoice for negative dollars or payroll data claiming an employee works 900 hours a week. Then there's the logical relationship check, which links facts together. A hire date for a new staff member can't be earlier than their birth date. Think of it as common sense built into the program. These controls aren't just about catching errors, they're about ensuring trust. If a program calculates salaries, for example, check digit systems, add an invisible extra layer, verifying that even numbers with typos don't slip through. Forensic-like attention is applied to reconcile totals after every stage of processing, ensuring the data is correct and complete by the time it's ready for its next phase. Output controls reliable reports fit for decision making. Imagine crafting a royal decree. It's got to be legible, stamped, and distributed securely to the right people at the right time. In IS, this is where output controls come into play. These controls ensure that once data exits the system, it's accurate, formatted, and lands in safe, authorized hands. For example, negotiable instruments like checks or payment outputs are as precious as coins or jewels. Systems log and verify these controls to ensure nothing is tampered with or misused. Reports, or the official record of the system, serve as tools for critical business decision making. But even reports can go awry if they're not cross-verified for accuracy and timeliness. And of course, the journey of output must always remain secure, whether stored on physical media, distributed electronically, or logged for audit trails. Output, at its core, is about ensuring the operations of the digital castle stand up to scrutiny when it comes time to show outcomes to the world. Application, controls, the backbone of the system. Here's a concept that ties it all together. Application controls. Think of them as the basic rules, principles, and instructions that every party in the castle agrees to for the whole enterprise to work seamlessly. Application controls govern input, processing, and output. They ensure that data entered are accurate, valid, and legitimate. Processing happens as expected, without errors or glitches. The final outputs align with goals, meeting the high standards of managers, decision makers, and auditors alike. What makes application controls special is how they synchronize with manual procedures to tackle complex situations, such as flagged exceptions or data verifications, giving the operations both agility and stability. Decision support systems, from data to insight. Finally, let's step into the modern throne room, where decision support systems, DSS, sit at the heart of strategic planning. These systems transform raw data into actionable insights, guiding leaders through dynamic and unstructured decisions. Imagine a wise counselor whispering scenarios, forecasts, and what-if analyses based on user input and historical trends. A DSS isn't just a tool to crunch numbers, it's an evolving assistant for executives and analysts. Whether it's sales trends, risk assessment, or exploring alternative scenarios, it draws from various sources and even applies AI for predictions. Its ultimate goal? Effectiveness. Unlike the hammering efficiency you see in transaction processing, DSS prioritizes flexibility, adaptability, and answering the right questions to help organizations achieve informed decisions. Conclusion: strengthening the digital castle. As our journey through this digital fortress comes to an end, it's clear that every piece, input, processing, output, application controls, and decision support systems, fits together in harmony to protect the integrity and usefulness of business information. These controls aren't just technical jargon, they're the heartbeat of every organization's digital DNA. Effective systems ensure not only that operations run smoothly, but also that the leadership has confidence in navigating challenges, risks, and opportunities. So whether you're an auditor, a developer, or a manager, mastering this interconnected ecosystem means leaving no stone unturned in building security, accountability, and innovation into the modern organization. Thank you for watching, and as always, continue learning. Stay curious, and we'll see you next video.